I just want to make a very small announcement. After the presentation, I'm planning to make a small contest. I will show you a code, and your task will be to find mistakes. And there will be prizes for that, which you can see in here. If I use all my time on the presentation, just stay with me, and well, then you will have bigger chances of winning because there will be less of you competing for that. I will make this contest anyway. Doesn't matter if we have 1 person or 10 person attending. Also, at any time, feel free to ask me. I'm organizing some open workshops this and next year, and I have some free slots for workshops if anyone is having budget and willing to use it. So feel free to approach me at any point, and especially after this presentation. Okay, are we ready? Yeah? Good? Good. Okay, so welcome everyone to Mistakes You Make Using Kotlin Coroutines. My name is Marcin Moskala. I'm a trainer, consultant, and developer, recently working quite often as a consultant or as a contractor for different companies, and I'm researching, I'm checking different projects and looking for mistakes, for ways to optimize the code to eliminate unwanted behavior. And I've noticed there more or less, like there are categories of mistakes that I can find again and again in different projects. And this is what I will show you here, the most probably obvious in a way, but also those mistakes that are repeating again and again in different projects, so the most basic 20 points that you should know about. So the first category is about incorrect use of coroutine builders. This is strongly related to what we actually use coroutines for, so for asynchronicity and for synchronization. So let's start from a very simple code. What's wrong in here? Here we have two asynchronous, here we have two suspending calls. They are both fetching some data. They could be, of course, made asynchronous. For that, we need to use coroutines code async await. And this is a very repeating code that we should use wherever we can make two things asynchronous. This speeds up the things. But on the other hand, quite often I see people misusing it or using it where it's not necessary. So using unnecessary coroutines, here you can see also async await, but notice that the second async needs to wait for the first async, so it's effectively a synchronous code. So async awaits in here are just confusing people and introducing nothing useful. So that should be one suspending call after another. Sometimes asynchronicity is useful and we want to have it, but we just use async await incorrectly. That surprises me whenever I see it. Async with immediate await, that makes no effect. I hope you can see why starting something asynchronous if you immediately await for its completion. And that effectively works just like if we had no async await. Yeah? This is a synchronous code in both cases. And if you want to make it asynchronous, you should spread asyncs in one place and await in the other. Another common misunderstanding and trap that mostly relates to the launch and coroutine scope is that if you use a launch in a coroutine scope, this doesn't really start an async process in relationship to this coroutine scope. Yeah? The launch in this case is a children of a coroutine scope. One of the rules of structured concurrency is that parent must wait for its children, so coroutine scope cannot complete before launch completes. So again, effectively speaking, this launch in here is useless. If we removed it, we would have exactly the same result. Yeah, we would have a synchronous code. And if what you want to have is a synchronous code, well, that's fine. That's the right code that is having its pros and cons. But if you want to if you want to be able to complete update user function without waiting for save user, the only right way to do that is to launch it on a separate application scope, okay? Or a view model scope, or any other scope you have access to. But the point is that not this scope of the coroutine scope function. Of course, a global scope is not the best choice. Why is it not? Global scope cannot be canceled. Well, they're not canceling application scope anyway, so maybe it's not that bad anyway, but global scope cannot be canceled. It cannot be overwritten for testing. That's probably the biggest problem. You cannot test it if you use a global scope, and if you want to introduce tests, then you need to replace all the global scopes, count them down, and you better be prepared in the first place. And it cannot be configured. You cannot set dispatcher or exception handler. Generally speaking, we should be using scopes that we injecting via constructor or creating in a class and injecting dispatcher. Both patterns are fine. Nevertheless, we should use some scope that is injected, or at least dispatcher is injected, and use it to launch an external coroutine independent from the current process. Another common mistake is incorrect use of run blocking. I say incorrect because run blocking is not incorrect per se. There are places where it makes sense, like in here, run blocking makes sense. This is a very common pattern on Android inside of the interceptor of a retrofit. If you need to get token, using run blocking is quite common because there is a thread that you can block, and because you need to await the completion of this process. If those two are true, then you can use run blocking. Here are a few examples when run blocking shouldn't be used. So here, we should never use run blocking inside of suspending functions, inside of coroutines. So no run blocking in here is pointless. You shouldn't use run blocking when you are not expecting any result. If you don't expect any result, just start something on the launch a coroutine on the scope. And you shouldn't use run blocking when this function might be started from a UI thread or a different thread that shouldn't be blocked. So in such case, we also use a view model scope or other scope, and we launch a coroutine. So another category, big category, very rich in problems category. So problems with cancellation. Let's start with an overview. In general, cancellation on Kotlin Coroutines works in the way that when you cancel the scope or a different coroutine, it cancels, and it cancels all children, that cancel all the children, that cancel all the children, and everything gets canceled. But coroutines cannot get ignored. They are not killed or forgotten. No, they must invoke their finally blocks. They must invoke their handlers, and that should be invoked in case of cancellation. So effectively speaking, they are resumed with exception, and this way they are finished as soon as possible while still calling their finally blocks and all the cleanups. So what can go wrong in here? Let's start from a scope that is misconfigured. A scope with a regular job is propagating and getting cancelled with its children being cancelled. So in here, if you have an exception on the launch, bam, it cancels coroutine free, propagates to the parent, cancels children, propagates to the scope. Scope is destroyed. It cannot be used for any other coroutine to launch anything. And also it breaks other children. Yeah? It cancels other children, which is very likely not what you want. So job is nearly never the right option for a coroutine scope. When you configure a coroutine scope, you typically should rather use a supervisor job. Supervisor job ignores its children problems, so an exception in coroutine free breaks parent, cancels children, but the scope ignores it and keeps running. Second, about the proper cancellation, that can sometimes be very problematic when you cancel the whole scope. Consider that you are here calling scope cancel. You cancel the scope, you cancel coroutine, you cancel its children, their children, all the calls, everything is canceled. Yeah, that's what we typically want. But you must know that scope cannot be used anymore. Yeah, the scope is useless. If you try to start something on this scope, it will just never start. Okay, so that is a bit can be a bit problematic, and I generally consider it safer to cancel children. Yeah? Scope, coroutine context, cancel children. This way, you still cancel all the childrens, all the coroutines, but the scope is still available for the future use. That costs us nothing, and that's just a simpler option. Another thing is when you start a few independent processes, coroutine scope is rarely the right answer because of cancellation. Cancellation that often works in favor of us when we use coroutine scope, async await, one of them gets canceled, the other gets canceled too. That's great. But the same process doesn't work well for the same mechanism doesn't work well for independent processes, like when you use a coroutine scope to launch a bunch of coroutines, the bunch of independent processes. What happens if one of them has an exception? Boom. The coroutine scope gets destroyed, cancels other children, and throws the exception. Yeah? For independent processes, that's probably not what you want. If you have independent processes, you should use supervisor scope. Yeah? Supervisor scope, again, ignores its children problems. And so an exception on launch gets ignored, and nothing gets canceled. Now, a very common mistake. People often think that the supervisor scope can be substituted with context supervisor job. They especially do that when they want to set something else, because for some reasons, supervisor scope doesn't allow an argument of a context. And, well, it cannot, okay? So if you should do something like that with context supervisor job, you are making two mistakes at the same time, yeah? First of all, it doesn't work like a supervisor job. It doesn't work because a job cannot be enforced from outside. Every coroutine has its own job. It's a life cycle of this job. It's a state of this job. You cannot force it, okay? So such a job will be the parent. And so first of all, if you have an exception on process 2, it breaks the parent with context that is using regular jobs, so cancels all the other children, and throws the exception. So this supervisor scope is effectively pointless in here. I mean, it's worse than pointless because it also breaks the relationship. So if you cancel the scope, then the with context and launches won't be canceled. So you have a memory leak, okay? So what you should do, you should use the supervisor scope. And if you want to also change a context, then the only way is to wrap it additionally with context. Yeah? That's the official pattern. That's the only right way to do that. Okay, more examples, because that's a very common source of memory leaks that I see. Whenever you use a job as an argument, you are breaking structured concurrency. Imagine that you are here using supervisor job or a regular job, doesn't matter. As a launch, notice that you have no relationship to the scope anymore. So first of all, supervisor job won't work as you would probably expect it to. An exception in the coroutine free breaks the parent, cancels children. This supervisor job is practically useless. But worse than that, if you cancel the scope, then coroutine 1 won't be canceled because it has no relationship. It's a children of a supervisor job, not a children of the scope. So that's breaking structured concurrency. The same if you use a job in any other place, like in launch in the middle of a coroutine, that's cutting off you from the relationship. That's really bad. I mean, if you do want to be cut from the relationship, you should use an external scope, like application scope or something like that. But if you don't want that, then don't use job as an argument. It's much safer to collect jobs returned from launches. Those can be canceled, can be joined. You can do whatever you want with them. Okay, so the same problem as before. Coroutine free won't get canceled when scope gets canceled. Another thing, I told you that in Kotlin, coroutines, cancellation mechanisms are based on suspending functions. Coroutine gets resumed with exception, or if it reaches a suspension point, bam, it throws cancellation exception. And that's great. It's a great mechanism, but it is based on suspension. Okay, it doesn't work if you have no suspension. And so if you have multiple CPU-intensive calls, like a for loop doing some things, or blocking calls, like you are operating on files one after another or something like that, this cannot be canceled. Yeah, because I mean, you won't be canceled in the middle because there is no place where the exception could be thrown. So this is bad. It's better to give space for cancellation, to be able to cancel it prematurely. And for that, we use one of 3 approaches, either yield, which is suspending and resuming. It is a bit heavier operation, but it gives us a space for redispatching. So if there is a queue for this dispatcher, we go to the end of the queue. The lighter operation, ensure active, an extension function and scope that throws cancellation exception if this scope is canceled. And the most flexible option is active. And if it is not active, you decide what to do, how to finish this coroutine as soon as possible. Another thing, common mistake. Again, I told you that cancellation is based on support from suspension. Effectively speaking, you cannot make a suspending call on a canceled coroutine. What means that if you do something in finally, okay, if this coroutine is suspended, maybe it reached this finally block because, sorry, if it gets canceled, maybe it reached this finally block because it gets canceled, this will never start. Yeah? Request database cleanup as a suspending call would immediately throw cancellation exception because the coroutine is currently canceling. Yeah? So all the blocks, all the suspending code or the code that creates children that should be executed for canceled coroutines, for canceling coroutines, should be wrapped with this special block with context non-cancelable. It is particularly made for such situations. If you don't do that, then in case of cancellation, this cleanup will never be executed, and you won't even know about it because there is no stack trace, no trace about it. But on the other hand, stopping cancellation exception is also bad. You know, it is especially common if you catch exception or a runtime exception, or even illegal state exception, because those are all parents of cancellation exception. We catch this exception thing. Okay, that's an exception from the function, but it might be also an exception that is the result of cancellation. And if it is, then you are stopping this exception, you are not propagating it further, and someone who would be checking, for instance, why it was finished wouldn't know why, or another function wouldn't know we are in the canceling process. So that's no good. There are 2 ways to handle that. One, quite a common thing, let's say traditional thing, is separately catch cancellation exception and rethrow it. And the other one, more recent one, there are some people who are advocating that recently, is to call ensure active. There are slight differences between them. We can discuss them if you ask me later. But for the sake of this presentation, I will just tell you there are some differences between them, and some people believe the right solution should be preferred. Now, a very Android-specific mistake. You see, there is a reason why we have the architecture where the view models are representing their state via mutable or via state flow that is observed by views, and not exposing some flows on. I mean, flow is fine in most cases, but not exposing some suspending functions or something like that. And here is a very clear example, very simple and clear example. Imagine that you are having a view that wants to fetch image, and it is using a suspending function from the view model. Okay, so if it succeeds, everything will be fine. But what if it fails? What if fetching image fails? That sometimes happens. You know, not only you will not load this image now, but you will also break the observer. So you'll very likely never load it. Yeah? The architecture that we are using, which is separating view models and views with the state flow. The state flow is observed by view, and that is updated by view models, is super safe. The observers are always safe. They will never be destroyed. They are working only when the value is updated and conflating it and eliminating duplicates, etc. So it is doing that effectively. And at the same time, if you have an exception on a coroutine, well, next time you ask, you will have another coroutine. Yeah? So that's a perfect situation. The last category, dispatchers misuse, also quite a big thing on Android. So let's start from basics. You cannot make blocking calls on coroutines. That's on Android, that's quite clear. Most coroutines run on the main dispatcher. Blocking main dispatcher means your application is frozen. Even such as small things like reading something from a disk can make your application frozen for a moment and can result in a poor user experience. Such calls should always be wrapped with an appropriate dispatcher, which is typically an I/O dispatcher, or if you are having lots of such operations, that's more for library creators, but well, generally speaking, if you have more of such operations, it's safer to make a specific dispatcher, an independent dispatcher with its own independent limit, and inject I/O dispatcher, of course, for testability. But on the other hand, we shouldn't inject it everywhere. Many projects are just using I/O dispatcher everywhere. Of course, I understand it's just to be sure, for safety, etc. But whenever you call a suspending functions, you shouldn't be needing to use an I/O dispatcher. Yeah, all the serious libraries, so practically all the libraries, when they provide a suspending API, they shouldn't block. That would be a very clear abuse of a contract. I mean, of course, if you don't trust the library, you can wrap it with dispatchers I/O to be sure. But if you are using a Room or Retrofit or any other big library like Ktor client, like man, you can use a suspend function directly. You don't need to wrap it with dispatchers I/O. Those libraries are using callback APIs. They don't block threads. Or if they do, they wrap themselves with appropriate dispatchers, so you don't need to do that, okay? Another thing, if you are not sure, if you eliminated your I/O dispatcher from the application, and then you are scared, what if I missed something? What if there is a blocking call somewhere that I don't realize? There is a library for hunting that. It's called Blockhound, and it is having a coroutines integration. So you just install it. You can install it in debug mode or in the end-to-end tests. And whenever you make a blocking call on a dispatcher that is not appropriate for that, an exception will be raised, and we should be notified about it. So check out the Blockhound and the integration. It is useful for hunting such situations. Of course, nowadays, instead of dispatchers main, we use dispatchers main immediate. It is also used by default by viewModel scope and lifecycle scope, and I believe quite everywhere. And the last thing is more of the architecture related. So most of our applications currently are divided into UI, view models, use cases, and data layer. And let's consider for a moment what dispatcher do we use on all those layers. And I believe the traditional architecture, which is used on many applications, and it's fine for many applications, looks like that. In the UI, we use a viewModel scope, lifecycle scope, which is operating on the dispatcher's main. On the viewModel, we use viewModel scope that also operates on the dispatcher's main, immediate, of course. And then we don't change this dispatcher unless we have to. Yeah? So we use this main on the use cases, on the data layer. Of course, if we need to block, then we wrap it with I/O. If you need to make CPU intensive, you wrap it with default. But outside of that, mostly we don't change the dispatcher. And if it's a small and simple application, that's probably perfectly fine. If you are not doing a lot of things, then it's probably fine. You are using one thread, but you are never blocking it, so it's okay. Huh? But the problem is, what if you are doing a lot of things? You know, it might be simple things. You are just serializing things that you receive from API, transforming them from JSON to DTO, from DTO to domain, from domain to something else. And you are doing a lot of small things. Yeah? Then this poor main thread might not be enough, especially on older devices. And you know, it might not have time for updating view appropriately, and it starts behaving less fluent. So in such cases, what should we do? We should start introducing dispatcher's default, especially around more intensive things. But in bigger applications, it's quite often around all the use cases to just wrap the whole business logic. Technically speaking, we could probably introduce it in view models as well. But we generally don't. I think it should be fine this way. View models should be, you know, lean, and most of the logic should happen above anyway. So view models can live this way. And if you run everything on main, it's much easier synchronization. So it is, it is also having some benefits. Okay. And the last one is. It's maybe not that much of a mistake, but it is annoying when people are defining, suspending functions that return flow. I mean, it's a bit of a nonsense. I mean, flow is a definition of a process that starts when you collect on it. Yeah? Suspend function is a function that starts doing something when you call it. Okay, so when you have a suspend function that defines a flow, it's doing some things when you call it, other things when you collect it. It is annoying to use it, and it is confusing when something actually happens. It is every suspending functions can be turned into a flow quite easily. The most simple approach is a flow builder and emit, and then this way you have regular functions that return flow. One value, suspend function. Multiple values, flow. Or if you want one value on a flow, that's also acceptable. Okay, and that's everything I had for you. If you want to learn more, there is the book and the workshop. There are a few open workshops soon, most of them in February, but there is also Kotlin Expert in December. And there are 3 last dates for a private workshop this year, and it might be much harder to organize a workshop with me in the beginning of the next year because I will be much more busy. And so if you want a workshop this year, is a good time. There will be a contest in a moment, but just to complete that was everything from my side. Thank you. That I wanted to make also here. I have some time for that. Do we have some microphones that can be given to attendees, or should they just be very loud? I don't know. Okay, so the rules are simple. I will show you a code in a moment. And if you find an improvement that should be made in here, I will tell you that you receive a book. Okay, whoever wants to stay with me. It should take, like, hopefully 5 minutes, but I will see how fast you are. Oh, that's a different project. This one. So here we'll practice synchronous, asynchronous. Oh, I'm not sharing. Can I share my screen again? I will be also signing them if you want them. Sorry, can you share my screen? Oh, okay. So, what's wrong in here? I mean, what can be improved in here? Someone can stand up and go ahead. Details and articles, perfect. That's the answer I wanted. Details and articles, but not token, okay? Token must be synchronously fetched because it's required for them both, yeah? So, but those two can be asynchronous, not parallel, but asynchronous. Stay with me. What do we need for that? async, but also coroutine scope. Yeah, we can wrap it around what we want to achieve or around everything. So coroutine scope, async. Oh wait, we have one person for now. What else? Who there is a? Sorry, speak up. The same article, okay, but we want all articles saved in the end. So what do we need for that? I want a different answer than await. Sorry? I want even different answer because there is a... I want a different answer than that. There is a pattern that I wanted to hear from you, and that is very, very useful. Not with context non-cancelable. However, it's quite close. Who will tell me how to? I mean, those all will be in the different lunches. But how can I synchronize all those? I already got this answer. Something different. Don't you know that? No, that's I hate it. No? Okay. No, I will qualify you for the lunch, but the trick, and we use it quite a lot, at least in the project I participated, is to use a coroutine scope. It is to practice that coroutine scope awaits all its children completion. That's a common pattern. I mean, if you want them asynchronous, if you want them independent, so an exception in one of them shouldn't break the other, not even a coroutine scope, but a supervisor scope. But from the point of synchronization, both of them are awaiting the completion of all those coroutines. So you don't need joins, you don't need await. That's the simplest way if you want to synchronize a set of operations. Okay, so that was one function. There is a different function. Here are a few other things that are wrong. I know the logic might be strange a bit, but it was, of course, to introduce as many problems in here as possible. Go ahead, you were first.
Cancellation exception instead of generic.
Yes, I will accept that. Sorry, I need to write it down. There are two ways how we can write it. Okay, we'll be next, but catch a cancellation exception, throw E. That's one, or a different way is to coroutine context ensure active. Okay, there is a different problem in here, but I will get back there. Sorry. So there was a guy who no. Okay, go ahead. Ensure active. Yes. So I also qualify you. Ensure active at where? Sorry? For 114. You want ensure active in here. Okay, that's the other way. But that's not what I want. You are already qualified, but what's your idea?
Save article is not suspend, so you don't have coroutine, so you cannot ensure.
Exactly. So here there should be either yield or ensure active. Yes. So ensure active I will use in here. But again, I cannot use neither of them because there is yeah, go ahead. Something more important. Okay. Something, what's screaming at us that it's wrong here, guys? Okay, go ahead. Recursion is intended. What's clearly? I want something else. Scream up. Run blocking, that's the keyword. Thank you. So I will qualify you. We don't want run blocking. It would be absolutely terrible to have run blocking in here, which function is called from the suspending function, yeah? I mean, from the suspending launches, and that would block, I mean, it would actually block I/O, but still, I mean, we would be out of threads quite, I mean, unnecessary quickly. So here there should be a suspend function. Oh my, I start losing that. I'm not sure if that's not done, but there is one thing that I wanted to show you. I intentionally used a recursion in here because I want to show you what happens if you forget about cancellation exception. What happens when you forget about cancellation exception? Yeah, the infinite recursion, yeah? So here I have a coroutine that is saving an article, but it is immediately canceling it. And so see what happens. We have infinite recursion in here, yeah? Why? Because here fetch articles is cancelled, so it's throwing cancellation exception. So we catch it and we try again, yeah? And I found such a thing in the real life application. So those are the consequences of cancellation exception. I think we found it all, but maybe I missed something. Oh no, I missed something. What's wrong in here? IO context, yes, that's the last thing with context dispatchers IO, because we have blocking calls and they must be made in an appropriate context. Yeah, I think we got it all. Do you have any question? Oh, wait a second. Now I need to set a type or use a block. Do you have any questions? Do we have time for questions? There is no one demanding stage, so what's the question?
Right. So that thing where you had an endless loop, have you seen that anywhere in production?
Yes.
Has a user found it?
It was visible in logs, and yeah, I don't know if it was that visible for the user because it was running on the background, but you know, it was probably consuming a lot of resources. Okay, if we have a moment for that, the difference is simple. Cancellation exception is thrown when the coroutine is cancelled and you make a suspending call. Yeah, but it's not the only that's not the only case where it is thrown. It is also thrown, for instance, by the function with timeout, which is actually quite controversial. Many people think it shouldn't throw cancellation exception. There are some other functions that are throwing it, some functions related to flow. And cancellation exception catches all these kind of exceptions, yeah? Whereas using ensure active is stopping this and breaking with exception only if the current coroutine is cancelled. So that's the answer. There was some, oh, you.
Under which condition should I expose the job from a suspending function? When should I
Expose a job from a suspending function?
return the job that's created? Like, for example, if I use with context, or if I returning the job from the suspending function instead of unit.
I mean, with context doesn't create a job. Launch creates a job. So you want to have a suspending function that starts a launch. So I cannot imagine it, honestly. Something like coroutine scope and launch inside of it. That sounds like a nonsense, because once the coroutine scope returns, this launch is already completed. So it seems like, I mean, to me it seems like a nonsense, but maybe some very specific use case might, okay. You know what I mean, like coroutine scope cannot complete before this is finished, so once coroutine scope is finished, this is completed. I mean, a completed job seems useless to me. Any other questions? No? People who got answered, who I told you to come to me, please come and I can sign it. And for the rest, thank you. And if you have any questions, come to me. I'm here, or find me on the conference.